314. 314. Now, in order to understand a new idea about pi this year, I need to teach you a little math vocabulary. All right, so we're going to start. We're going to have an equation, y is equal to 1 over x. And what we're going to do is plug in values for the x and see what happens to the y. So this is like, let's see, 1 over x. It's like having one pizza and sharing it with x number of people, right? So if we share it with just one person, meaning we just eat it ourselves, then y is still 1. But if we share it with 10 people, then y turns out to be 0.1, right? If you share it with 100, then y is 1 out of 100. So it's 0.01. And what's happening as the x's get larger and larger and larger? You see the y's up there are getting tinier and tinier and tinier. And they're almost, but not quite 0. So if you said that I divided up this pie among an infinity number of people, you said, oh yeah, each piece is 0 big, you would be wrong, but you'd be awfully close to right. Okay, so now here's your vocabulary. Okay, we can say, instead of, hey, we're wrong, but we're close to right, we could say that the limit of y as x gets closer and closer to infinity is 0. So we could use the word like limit. Or we could use the word approach. The values of y approach 0 as x approaches infinity. Oh, the build-up. Or we could say y asymptotically approaches 0 as x gets bigger. And the idea of getting closer and closer to something and coming in on a limit is one of the basic ideas of calculus. So let's have this. Okay, so this is what Archimedes did. Yeah, that was exciting. Okay, this is what Archimedes did with this idea of limits. He lived about 1900 years before calculus was formally developed, but he could anticipate these ideas. And he was interested in estimating a value of pi. But as you know, pi is a transcendental number. It's irrational. The digits go on and on. They don't stop. They're always changing. You can't predict them. And so it's kind of hard to exactly figure out and list all those digits. But this is what he thought. Now, we kind of sort of in order. Triangle, square, pentagon, pentagon. Come on over here and hold up this hexagon. This is what Archimedes did. This is a simplification of what Archimedes did. The Greeks were really good at geometry. They developed a lot of formal geometry, right? So they knew how to get the perimeter of polygons. Polygons are these kind of shapes. They're closed figures that are formed by line segments, right? And so Archimedes knew how to sum up all the sides and get the perimeter. So he figured the following. If he could inscribe a triangle, for example, inside a circle, then the perimeter of the triangle would be kind of sort of close to pi, because the circumference of a circle is pi times the diameter, okay? But he could try to get even closer if he moved up to a square, right? And the perimeter of the pentagon would be even closer to the circumference of the circle. Hexagon, it's getting hard to see, right? In fact, if you sort of roll these or twirl them along, well, maybe not in a triangle, but eventually it would be hard if you're going fast enough to distinguish between the polygon and the circle. He actually did this both on the inside and the outside and got some boundaries for it, but we'll just imagine paying attention to inscribing the polygons inside. And he was able to calculate the perimeter of a polygon inscribed in a circle with 96 sides. So if you look at these, you can imagine that by the time you hit 96 sides, basically it looks an awful lot like a circumference. And doing that technique, he got accurate to about, did I say how much? 3 decimal places? Yeah, 3 decimal places. Not bad for the ancient world. And you can see here how, even with 12 sides, it looks an awful lot like a circle. Because pi is 3.14159265897932346, etc. And by the time we're at where Archimedes stopped, we're already up to 3.139. That's awfully close for intuiting. Okay, so let's see another slide. So he was close to right. Not exactly right, but close to right. And so we can use our vocabulary now. We could say the limit of the perimeter of an n-sided polygon as n approaches infinity approaches pi. Or we could say that the perimeter of the inscribed polygon asymptotically approaches pi. Woohoo! All right.
Yeah.
So what happened to Archimedes? Why didn't he actually go on and discover calculus? Well, this is what happened. The Greeks didn't have a lot of paper around, right? That was a rare, something to write on would have been rare in the ancient world. So this is how he did his work. He would work outside in the sand. He'd have a stick, and he'd draw out his figures and his proofs in the sand. And that's how he met his death. Because during the Second Punic War, the city he lived in, Syracuse, was under attack by the Romans, and the general Marcellus, I think his name was, put in an order to the Roman soldiers not to disturb Archimedes, because Archimedes' fame was really widespread. But one particular soldier did not follow these instructions. He came upon Archimedes working in the sand and ordered him to move along. Archimedes was totally engrossed in his proof. According to legend, his last words were, "Don't disturb my circles," and the soldier slew him with the sword. And that was the end of Archimedes. So, now you know a little bit about estimating pi, you have some new math vocabulary, and you know how Archimedes died. So, we're almost done. Except that if you didn't pick it up the first time, I thought I might review it with you now. I do my math work in the sand. That's my intention. I started my proof stick in hand. Took concentration. That's just what I'm used to. No paper to write on. I'm curious for pi. Caught my attention. I took a twirl and I left it. I came up at the limit. I took a whirl just to try it. I came up asymptotic. It came out wrong, but close to right. Don't mean that pi's not inside. I took a twirl and I liked it. Asymptotic. No, he did not know of my fame. It sure didn't matter. He hunted me like I was game. Just it's just what the Greeks do. No documents to save. My head gets so confused. Hard to obey. I took a twirl and I liked it. I came up at the limit. I took a whirl just to try it. Hope that soldier don't mind it. It came out wrong, but close to right. Don't mean that pi's not inside. I took a twirl and I liked it. Asymptotic. Us Greeks, we are so